Today we're going to look at the properties of exponents, and we're going to use our integer values today, and this is going to lead us into being able to use rational exponents later on. This should be a review from Algebra 1, however, if not, here we go. Our first property is if I take two bases that are the same and multiply them together, what do I do with the exponents? Well, in this case, I want to add those two exponents together. An example of this that we've seen in the past would be x squared times x to the fifth. Here, I want to multiply, so I'm going to keep the same base. I'm going to add the exponents. So we have 2 plus 5 gives us a 7. So I multiplied the two bases, which I keep the same base, and I add the exponents. If I do division, here I'd have a to the m divided by a to the n. To divide, instead of adding, which I did in multiplication, here I'm going to subtract. I'm going to take m minus n. Example here would be if I had x to the fifth divided by x to the third. In this case, I take 5 minus 3, which gives me x squared. Now you may be asking yourself, well, what happens if the smaller number is on top? So another example, if I had x to the third over x to the fifth, this would reduce. Now instead of taking 3 minus 5, I'm going to take the larger number, 5 minus 3, and get 2, but I'm going to leave it on the bottom. So notice the difference if my exponent is larger on top than on bottom, or if it's larger on the bottom than on top. I still get a fraction if it's larger on the bottom. The next one that we want to look at is if I have a quantity, say a to the m, b to the n, to an exponent. Let's say that this is to the exponent of r. I can simplify this by taking this r and multiplying it to each of these exponents. This only works if we're multiplying everything in that quantity. So here we're going to take a to the m r, b to the n r. So an example of this might be if I have x squared y to the third, and I take it to an exponent of maybe 4. So here I'm going to take x squared to the fourth, so I'm going to multiply these exponents and get x to the eighth. For my y's, I'm going to take my 3 times 4, and I'm going to get y to the 12th. My next rule that I'm going to work with is something that has a negative exponent. So if I have a, say to the negative m power, our rule is going to be, if it's a negative exponent, it's going to move it on the opposite side of the fraction. You may be asking yourself, I don't see a fraction. Well, if we put this over 1, we've created a fraction. So what we're going to do is take this a to the negative m, the base and the exponent are going to move to the bottom. So we'll have a, and then the exponent is going to change signs. So that negative m is going to become positive m. We have nothing left on top, so to keep that place, we're going to put a 1. An example of this, which isn't going to be much different, would be if I have x to the negative second. This is going to give us 1 over x squared. Now if I had, say, x to the negative second and a y to the positive third, in this case, I'm only going to move the x to the negative second to the bottom. So I'm going to make this a fraction, and it's going to go to the bottom. So to simplify this, we're going to have y to the third over x squared. Likewise, if the negative is on the bottom, we can bring it to the top. So if I have 1 over a to the negative n, this is going to allow me to bring this a to the negative n to the top as a to the positive n. Example of this would be 1 over x to the negative third. This x to the negative third is going to come all the way to the top, and we end up with x to the third. The next property that we want to talk about is the zero power. If I have a to the zero power, what does that equal? In a lot of cases, people say 0, but actually that's not true. Let's come off to the side and talk about our exponents for just a second. If I were to give you 2 to the third, 2 to the third power, we know is 8. 2 to the second power is equal to 4. 2 to the first power equals 2. So if we look at the pattern here, as I decrease my exponents by 1, I'm dividing this number over here that it's equal to. So if I continue this pattern, subtracting 1 here, I want to continue the pattern here by dividing by 2. So 2 divided by 2 gives me 1. So in this case, a to the 0 is going to be 1. Now if we continue this pattern, decreasing 0 by 1, I get negative 1. If I take 1 divided by 2, I get 1/2. So we should see that we bring in this topic of having a negative exponent as well within this example. Notice 2 to the negative first, we make it a fraction as 1 over 1. That 2 to the negative first comes to the bottom, which gives us the 1/2. 2 to the negative second would be 1 over 2 squared, or 1/4. Hopefully you see a pattern here where 2 to the first, or 2 to the negative first, is simply 2 to the first under the 1. 2 to the negative second is simply 2 to the second under the 1. So we have 1/4. And that would continue as a pattern throughout. So it doesn't matter what number we take to the 0 power, we always get 1. So if we had 50 to the 0 power, it gives us 1. Very important rule, and a lot of people mess this one up, so be careful. You may want to star this one. A to the 0 equals 1. We have one last one to talk about, and it kind of goes along with our multiplication at the top and division. If I have a to the m over b to the n, and I take this to the r power. Since I have a fraction here, and both of them are being taken to the r power, to simplify this, I can take that r and multiply it into both of these exponents. So I get a to the mr divided by b to the nr. An example of this, and we'll put this down here, if I give you x to the third over y to the fifth, and say we take it to the second power. To simplify this, we can multiply these exponents together. So I get x to the sixth over y, 5 times 2, to the 10th. And that would be an example of simplifying a fraction to an exponent. So now that we've looked at our properties, we can go ahead and look at some examples of these properties and what we're going to ask you to do with it tonight. So example 1, let's say I give you the quantity of 3 x squared y to the negative fifth to the second power and ask you to simplify it. Well, in this case, what we're going to do, since we have a quantity to an exponent, we're going to take this exponent and multiply it to each of my exponents inside this quantity. You may say, hey, we only have 2 of them here, but really we have 3, since 3 has an exponent of 1. So we're going to multiply this 2 to all 3 of those exponents. And we end up with 3 squared times x to the fourth times y to the negative 10th. Remember, we multiply those exponents in. Well, now we can take 3 squared. 3 squared equals 9. We have x to the fourth and y to the negative 10th. Since we don't like negative exponents, they just don't look very nice. we're going to take that negative exponent and move it. Since it's on the top, we're going to take it to the bottom. So our final answer, nice and clean, is 9x to the 4th over y to the 10th. In example 2, let's get a little more complicated. Let's say we had 2x squared times 3y to the 3rd divided by x to the 3rd, y to the 4th, and we take all of this to the negative second power. Well, there's several things that are happening here. To clean this up to begin with, we would go inside the brackets, like we normally would with an equation, and simplify what we can. In this case, in our numerator, we have 2x squared times 3y to the 3rd. We can clean that up to 6x squared, y to the 3rd. And on the bottom, we have x to the 3rd, y to the 4th. And that's to the negative second power. Continuing to clean up inside the brackets, we can use our division rules there. We have x squared over x to the 3rd. Here, we're going to subtract those exponents. We have more x's on the bottom, so they're going to stay on the bottom. So our 6 is on top. 3 minus 2 gives us x. Remembering it's going to be on the bottom, since there were more to start on the bottom. Our y's are going to continue to stay on the bottom, because we have 4 minus 3, which gives us to the first. And this is all going to be to the negative second power. At this point, there's a couple things that we can do. We can take this negative 2 and take it to each of our exponents, or we can think about that negative exponent. Remember that negative exponent is going to make it a fraction, taking the things on the bottom to the top and top to the bottom. So we can clean this up, and what I like to do is, since it's negative, go ahead and flip this fraction. So everything on the bottom is coming to the top, everything on the top is going to the bottom. So we get xy over 6, and this is to the positive second power. Notice we went from a negative to a positive, and our fraction flipped. Now we can finally clean this up by taking that 2 and multiplying it into each of our exponents. Remember, if there's not an exponent with it, it's going to be a 1. So we get x squared, y squared, over 6 to the first squared, so we get 6 squared, or 36. So you can see it. There's our answer, x squared, y squared, over 36. Now in example 3, let's go ahead and combine a few more of them together. Let's say we take a quantity of 12 x squared y to the negative 3rd, z to the 0, all to the second power, divided by 3x y to the negative 4th, z. So here, if we go inside those parentheses, there's really only one thing that we can clean up, and that's the 0 power. Remember, anything to the 0 power is 1. Well, here we have 12 times x squared times y to the negative 3rd times 1. So 12 times 1 still ends up with being the 12, so we can really eliminate that 1 altogether, since we don't need it as a place value holder. You may be saying, well, why don't we take this negative exponent and take it to the bottom of our fraction? Well, we can't take that negative exponent down yet because it's being squared within this entire quantity. So at this point, we can take our 2 and distribute it to each of our exponents. Taking that 2 to our 12, we get 12 squared, or 144, x to the 4th, y to the negative 6th, divided by 3xy to the negative 4th, z. Now we can go ahead and clean up. Well, there's a lot of things that we can start with. What I would suggest that we do is take 144 divided by 3. Well, in this case, we end up with 48. Looking at our x's, we have x to the fourth and we have x. So subtracting those exponents, 4 minus 1 gives us 3. And then on our y's, we have y to the negative 6. This is going to move to the bottom, and our y to the negative fourth is going to move to the top. So we'll end up with 6 on the bottom, 4 on top, gives us a net 2 on the bottom. 6 minus 4 gives us the 2. Remember, we've brought this one to the bottom, negative 4 to the top. And then we're going to leave our z alone on the bottom. And there's our final answer, 48 x to the third over y squared z. And let's go ahead and look at one last example. I know it's getting to be a long one, but if we look at one last example, x to the fourth. Let's say I give you 3xy squared over z to the negative fourth times 2x to the second y to the negative third, and we'll put it over z. Here we have a fraction times a fraction. We're going to do this basically the same way. We're going to clean up each of the parts to start with, and then go ahead and multiply together. So here we have a negative exponent. It's going to come to the top. So we end up with 3xy squared z to the fourth times, here in our second fraction, that y to the negative third is going to go to the bottom. So we have times 2x squared over y to the third z. We can make this a fraction or continue it as a fraction as putting it over 1. And then we can go ahead and multiply across. So we have 3 times 2 gives us 6. We have x times x squared gives us x to the third. And then our y squared z to the fourth come across as well. And then in our bottom we have 1 times y to the third z. So we're going to just go ahead and bring them across. Now that we have a single fraction, we can go ahead and clean this up. Looking at our y's, we have 3 on the bottom, we have 2 on the top. So we're going to leave our 6 and our x to the third alone, but we're going to end up with 1y on the bottom. 3 minus 2 gives us y to the first. And then z to the fourth, and we have z on the bottom. We go subtract those exponents. Remember, there's a 1 if there's no exponent. So 4 minus 1 gives us 3. We start it with more on the bottom, more on the top. So we're going to end with more on the top. So we have our z to the third on the top. And that concludes our properties of exponents, which, remember, if we're multiplying common bases, then we're going to add their exponents. If we divide two common bases, we're going to subtract their exponents. If we have a base to an exponent, we're going to multiply each of those exponents for the bases. If we have a negative exponent, we can move it. If it's on the top, we can move it to the bottom to make it positive. If it's on the bottom, we can bring it to the top, making it positive. We have a to the 0, or anything to the 0 power, gives us 1. And if I have a fraction to an exponent, I can distribute that exponent to all of our exponents on the inside of that quantity through multiplication. And that concludes our properties of exponents.